Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. Okay, so as you see on the screen, then here we are now chapter 7 of trigonometric functions with 7.1 trigonometric ratios and identities. So get ready with your lecture notes, and we begin we're going to start the lecture now. Okay, so in this topic we are going to look into all the trigonometric ratios of sine theta, cos theta, tangent theta, cosecant theta, secant theta, and cotangent theta. And all those things that you see on the screen here, and also we call the Pythagorean identities. Okay, so then just imagine that there is a we call triangle on the first quadrant of this we call x and y axis. So we can look into the trigonometric identity ratios sine, cosine, tangent, secant, cosecant, and cotangent. Okay, so for example here, this is the angle of that triangle on the first quadrant. Okay, so we got O stand for opposite, H hypotenuse, and A adjacent. So sine theta equal to opposite divided by hypotenuse. Cos adjacent divided by hypotenuse, and tangent opposite divided by adjacent here. So then cosecant, secant, and cotangent. So then we also gonna discuss on the we call ratios of any triangle, of any angle. So we got 4 types of angle here. Acute means that the theta lies in between 0 until 90 degree. Right angle, obtuse, and also reflex angle. So the example number 1. Given that sine theta equal to 3/5 and theta is an acute angle, find the cos theta and tangent theta. Okay, before that, let's refresh our we call knowledge about triangle. Okay. So this is a 90 degree right hand angle, and let's say this is the theta. So theta is sine theta equal to 3/5 opposite 3 divided by hypotenuse, which is 5. So please refresh our lesson we call knowledge about this. Okay, so then let's say we name this one as an x. So our previous knowledge about this, we use the we call the Pythagoras theorem of x squared plus y squared equal to z squared. Okay, so x squared plus 3 squared equal to z, the hypotenuse, which is 5 squared. Then x squared equal to 5 squared, 25. 3 squared equal to 9, bring the side become negative, minus 9 equal to 16. Then x equal to plus minus 4. Square of 16 equal to 4. Okay, positive and negative 4 is not that the value of x. X is a measurement here. It cannot be negative. But the sign of negative here shows the direction whether to the left or right. Okay, so it means that here these values of x equal to 4. So if this is the we call the x-axis, the origin point, to the 4 on the left side means that is 4 to the left or negative 4. Okay, now let's get back to this one here, acute angle. So okay, x and also y axis. Okay, then sine theta equal to 3/5. So just imagine that we got 3 here, and from origin point, okay, there you go. Okay, so then theta Yeah, equal to 3 and 5. Okay, so we have this recall, counted just now, then this is equal to 4. Okay, so find cos theta. So then cos theta equal to cos adjacent, which is 4, divided by hypotenuse, which is 5. And tangent theta equal to tangent opposite divided by adjacent, which is 3 over 4. Okay, that's it. So cos theta equal to 4 over 5 and tangent theta equal to 3 over 4. Okay, let's now, if tangent theta equal to negative 1 over square of 2 and theta in the fourth quadrant. Fourth quadrant, so fourth quadrant, we can just imagine that this is an X and also Y. This is a first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, so in the fourth quadrant, meaning is in this area, so find the cosecant theta and cosecant theta. So we're going to sketch the X and also Y axis. X and Y. Okay, in the fourth quadrant, so then it's going to be something like this. Okay, tangent opposite divided by adjacent. And from this triangle, okay, from this triangle, and this is the theta. So tangent opposite divided by adjacent, which is 1, negative 1, and also square root of 2. So opposite, look at that, we call the distance of vehicle, we call for this one here until up to negative 1 until here, and adjacent for x-axis, which is square root of 2. Okay, so then secant theta equal to 1 over cos theta. So meaning here we need to find out what is the value of cos theta. So cos equal to sine. Cos adjacent square of 2 divided by hypotenuse. Okay, before that we need to find out what is the value of this. So and again from here, okay, this is hypotenuse. So x square, which is square root of 2 square, plus this one negative 1 square equal to square of 2 square, then equal to 2, plus negative 1 square equal to 1, then it is equal to 3. Okay, so please refresh that, recall the Pythagoras theorem from x squared plus y squared equal to z squared. And 3 considered as an z squared, so then z equal to square root of 3. So it means that, recall the hypotenuse of this triangle is square root of 3. Okay. Now, okay, I'm sorry here. Square root of 3. Okay, so then cos adjacent square root of 2 divided by hypotenuse, which is square root of 3. So then 1 over cos, which is square root of 2 divided by square root of 3 equal to square root of 3 divided by square root of 2. Okay, then cosecant theta equal to 1 over sine theta. And from here, sine theta, sine opposite, which is -1 divided by hypotenuse of sine opposite divided by hypotenuse, square root of 3. So then this one here come up with 1 over sine -1 divided by square root of 3. Then it is equal to negative square root of 3. Okay, now relation between sine, cos, and tangent. Okay, so I may also define this an angle of alpha. Okay, and the inner, so we call angle of this triangle. This is 90 degree. So then 90 degree plus with theta plus with alpha equal to 180 degree. So sine 90 degree minus theta 90 degree minus theta, so we consider this one as an alpha for this one here. So sine of this angle, sine opposite divided by hypotenuse, x divided by r. So then, okay, cos 90 degree, this is we call, and cos 90 degree minus theta, or alpha here, 90 degree minus theta, we name it as an alpha. So cos alpha equal to adjacent, which is y, divided by hypotenuse, r. And also tangent, tangent opposite divided by adjacent here, x divided by y. Okay, and also equal to cotangent of x over y. And this is what we call the changes of value of the degree to radian and radian to degree. Okay, trigonometric ratios for special angles. So guys angles. So you may refer to these notes, or you may also refer to some other some other reference book. They sometimes they begin with 0 degree, 30, 45, 60, and 90. Okay. So never mind, please refer to this one here now. And also here. Okay. Graph of sine, cosine, cosine theta, cos theta, and tangent theta. Okay. Y equal to tangent theta. And this we call this the graph of the tangent theta then. So example 3. Prove that cos 60 degree equal to 1 minus tangent square 30 divided by 1 plus tangent square 30. Okay, for this one here. Okay, so we call tangent 30 degree. So we may refer to the previous chart of this table. Okay, tangent theta or tangent 30 degree equal to 1 divided by square root of 3. So then, from here, we're going to come up with 1 minus tangent square 30 degree or tangent 30 degree, which is 1 divided by square root of 3 square divided by 1 plus 1 divided by square root of 3 square. Okay, so then here, okay, tangent 30 degree, which is 1 over square root of 3, and also here 1 divided by square root of 3. So the square, then 1 over square root of 3 in bracket square. So then become 1 minus, okay, so 1 square equal to 1, and 3 square of 3 square of 3 square equal to 1 over 3 divided by 1 plus 1 over 3. Okay, for this one here, 1 over square root of 3 square equal to 1 square divided by square root of 3 square. Then it is equal to 1 divided by 3. So then 1 minus 1 over 3. Consider this one as a 3 over 3. So 3 over 3 minus 1 over 3, 2 over 3 divided by 3 over 3 plus 1 over 3 equal to 4 over 3. Okay, so then it equal to 2 over 3 multiplied with 3 over 4. Okay, so then 2 divided by 4 equal to 1 over 2 and 1 over 2. 1 over 2. 1 over 2, which is 60 degree. Cos of 60 degree equal to cos 60 degree. This one here. Okay, we begin the process from the right side here, and we end up with 1 over 2 or equal to cos 60 degree equal to 1 on the left side. Okay, and next is secant 30 tangent 60 degree plus 45 degree and secant 45, and as you see then here equal to 7 over 2. Okay, so then the solution of this from left hand side, okay, let's say from left hand side, secant 30, okay, you may refer back to the table of the sine, cos and tangent, the special angle that you see just now. So secant 30 equal to 2 divided by square root of 3, and then tangent 60 equal to square root of 3 plus with sine 45, 1 divided by square root of 2, and cosecant 45 equal to square root of 2 plus with cos 30 degree equal to square root of 3 divided by 2 multiplied with cos 60 degree equal to 1 over square root of 3. Meaning, okay, secant 30 degree, tangent 60, sine 45, cosecant 45, cos 30 degree, and cotangent 60 degree equal to, okay, square root of 3 divided by square root of 3, square root of 2 divided by square root of 2, and square root of 3 divided by square root of 3, and this is equal to 2 plus 1 plus with this one here 1 over 2. Okay, 2 plus 1 equal to 3 plus 1 over 2. Okay, change this this number 3 into the fraction of 1 over 2 here with 6 over 2. 6 divided by 2 equal to 3. And plus 1 over 2 equal to 7 over 2. Okay, equal with the value on the right hand side here. Okay, so then okay, so this is all the basic angle, and the big angle can be in the first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, so means that if the basic angle here, the triangle lies situated in the first angle here, first quadrant, then the sine, cos, and tangent of alpha is all positive for sine, cos, and tangent. But in second quadrant, it's only positive for sine, but the rest of cos and tangent negative. And for the third quadrant, it's only positive for tangent, but it's negative for sine and cos. And for fourth quadrant, it's only positive for cos, but negative for sine and tangent. Okay, so then, okay, positive and negative angle. If this is the angle, okay, class, all the angles begin from the right side of this x-axis. Okay, so if from here it move according, okay, please refer to the angle arrow. Okay, the direction of the arrow from here to this line of A, we set this one in opposite of what we call anti-clockwise direction, and this is clockwise direction. So for this is positive and negative here. Okay, if I give you the idea of this, okay, any triangle, okay, so then this is negative 3, 4, and 5. So then, let's say theta here, sine theta, okay, sine theta, sine opposite negative 3 divided by hypotenuse, which is 5. Cos theta equal to adjacent 4, which is 4, divided by hypotenuse is 5. 4 over 5. And tangent theta equal to opposite divided by adjacent, which is negative 3 divided by 4. Negative 3 divided by 4. So please refer to this one here now. Sine is negative. Cos positive. Here positive 4 over 5. And tangent negative with negative here. Okay. Example 5. Okay, sine 330 degree. And also, so the first one here, A equal to sine negative 330 degree. Okay, but before that, okay, so negative 330 means that from here, negative means that it's an anti-clockwise direction. 90, negative 90, negative 180, negative 270, and negative 330 degree. There you go. Okay. And then from here, we take this basic angle of alpha here, of this, sine negative 330 clockwise direction is end up here in the first quadrant, so equal to negative sine 360 degree minus 330 degree equal to, okay, and then with negative here, negative sine 330 degree. So we got negative waiting outside here. So negative sine of 360 degree equal to positive of sine 30 degree. And this is 1 over square root of 2. And what about cos negative 225? Cos negative 225 degree equal to negative cos 225 degree minus 180 degree. Okay, the angle is negative 225. Again, it's a clockwise direction from here to negative 90, negative 180. Okay, so negative 90 and negative 180 and negative 225, somewhere around here. Okay, so it lies in second quadrant. So we take this basic angle. So negative 225 minus 180 equal to negative cos 45 degree. So then here it is negative cos 45. You may refer to the, we call the table. And it is equal to 1 over square root of 2. Okay, so then trigonometric identities, as I said earlier, I mentioned about this r square yz square, x square equal to y square. Some books they stated this one as a z, and in this note they stated as an r. It's okay, it's just a symbol. So then divide by, okay, for the equation of this, r square equal to x square plus y square, then divide by r square. Okay, then it is equal to, from the graph of cos theta and sin theta, and it gives you 1 cos square plus sin square equal to 1. Okay, this is the first trigonometric identities. Sin square plus cos square equal to 1. Then from sin square plus cos square equal to 1, when divide by cos square left and right, all left and right, okay, 1 divided by cos square divided by cos square, and sin square divided by cos square. Okay, this automatically give us equal to 1. Sine over cos equal to tangent, am I right? So sine square plus cos square. Yes, that's it, tangent square. And 1 over cos is secant. So 1 over cos square is secant square. There you go. And also, from the equation 2, divide by sine square. When you divide by sine square, and of course this one here is going to give you equal to 1. Then 1 over sine is cosecant, cos over sine is cotangent, so if we square and square here, then it becomes cosecant square equal to cotangent square plus 1. So now we got all these trigonometric identities that we're going to use sometimes in some questions. Okay, just ready then. Prove the following identities. Okay, so which I think that this question quite familiar to all of you, especially in last time during your SPM studies then. Okay, first one here. Okay, sine plus cos, sine theta plus cos theta square plus with sine theta minus cos theta square equal to 2. Okay, so we begin from left side. You may begin the process from right side. It's all up to you. But you have to be careful if you begin from the right side. For example, for this 1 equal to 1, what is your idea to begin the recall process until you get something equation that equal to the left side? Okay, for this case, I begin from the left side, from the left hand side. Okay, so then here sine theta plus cos theta plus sine theta minus cos theta. I forgot squared here, squared left and right. So then expand this. I'm going to give you sine squared theta plus 2 sine theta cos theta plus cos square theta, and expansion of this sine theta minus cos theta in bracket square equal to, okay, plus this one here plus with sine square theta and then minus 2 sine theta cos theta and then plus with cos square theta. Okay, so look at this one here now. 2 sine theta cos theta and negative 2 sine theta cos theta. They cancel each other then. Okay, and then what do you find out here now? Okay, sine square theta, this one here, and then plus with cos square theta plus with sine square theta here, and also this one here, cos square theta. Okay, do you still remember one of the identities we found it earlier from this question? Sine square theta plus cos square theta equal to 1. Good. So from here, we got two terms of sine square plus cos square. So it means that it is 1 plus 1 equal to 2. Equal with the term on the right side, which is equal to 2. And then question B, 1 minus cosecant square theta multiplied with 1 plus tangent square theta equal to negative cosecant square theta. Okay, you may begin the process from the right side. Again, it's all up to you. Okay, as long as you can solve it until you get it. If you begin from the right side, then you get equation something that equal with the term on the left side. Or if you begin from the left side, then you find it with the end up with something that equal the one on the right side here. Okay, so now if I begin from the left side, okay, so 1 minus cosecant square theta and then 1 plus tangent square theta. So then 1 multiplied with 1. Yeah, you may expand it, but sometimes that we have to think the other way around. Okay, sine square theta plus cos square theta equal to 1. Okay. Let's say this is equation 1. Let's say sine square plus cos square equal to 1 divided by sine square. Sine square divided by sine square equal to 1 plus cos square divided by sine square equal to cotangent square theta divided by sine, cos over sine, and 1 over sine is secant square theta, equation 2. And sine square plus cos square equal to 1 divided by cos square. So sine over cos is tangent square theta plus cos square divided by cos square equal to 1, and 1 over cos square equal to secant square theta. Sine square divided by sine square equal to 1. Cos over sine is cotangent, and 1 over sine cosecant here. Sorry. This is cosecant. Okay, not secant, but not secant, cosecant for this one here. Okay, I'll make a correction here. Okay. And for this one here, which is cosecant square theta. Okay, equation 3. Look at this one here, 1 minus cosecant square. If I bring this 1, okay, if I bring this cosecant to the left side, become negative, and cotangent here become negative. So we get here now, it is negative cotangent square theta. Okay, elaborate this from equation 2. Okay, so bring the cosecant square to the left side, so 1 minus cosecant, and cotangent square bring to the side become negative, so negative cotangent square theta, and 1 plus tangent square, 1 plus tangent square, or tangent square plus 1 equal to secant theta. Okay, so now negative cotangent square is cos square theta divided by sine square theta, and then secant is 1 over cos square theta. So cos square divided by cos square, then it is negative 1 over sine square theta, which is equal to negative cosecant square theta, equal with term on the right side. Okay. Example 7, prove the identity of secant theta minus tangent theta. Okay, for this one here now. So for this example, I'm going to begin the process from the right hand side. Just now from the previous 2 examples, we begin from the left side. Okay, right now I begin from right hand side here. Cos theta divided by 1 plus sine theta. And class, for this one here, sometimes we have to think of something that we might might not predict what we're going to do, but then we can come up with some ideas here. Okay, to simplify this, 1 plus sine theta. For this one here, I come up with cos theta divided by 1 plus sine theta. And we are going to multiply with the opposite of this. We might say is we call a conjugate, but not really one. But something like this one here. 1 minus sine theta 1 minus sine theta. Okay. So then, cos theta multiplied with 1 equal to cos theta. And cos theta multiplied with negative sine theta minus cos theta sine theta. And everything divided by 1 times 1 equal to 1. Okay, so 1 times 1 equal to 1. 1 times negative sine and positive sine cancel each other, and minus sine square theta. And then 1 minus sine square theta plus cos square theta equal to 1. So then 1 minus sine, bring this to the right side and become negative. So cos square theta equal to 1 minus sine square theta. So 1 minus sine square theta we can replace with cos square theta. That's it. So cos theta minus cos theta sine theta divided by cos square theta. And now, it's either you, okay, class is something like this. We have x minus xy divided by y, okay, not y, okay, divided by x square. Do you think that we can just simply simplify this? X divided by 1 of the x with x here, it come out with 1 minus y divided by x. Am I right? Okay. So in this case, the cos divided by 1 of the cos is 1 minus sine theta divided by cos theta. Okay, so then next here, we separate this into two, 1 over cos theta and minus, okay, minus sine theta divided by cos theta. So 1 over cos is secant theta, and sine over cos equal to tangent theta. So we begin the process from the right side here, and we end up with secant theta minus tangent theta is exactly the same. Prove that, and then we call from the left side here, so prove identity of this. So that's all for today for our lecture for this part. Thank you very much. Until we meet again, Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.